Hi guys, we're looking at chapter 24, section C now, and this is looking at the normal distribution, but now the standardized normal distribution. Another name for that is the Z distribution. So let's recall for a minute. Back in sections 24A and B, we looked at any data set that was normally distributed. And when that happens, we can use this notation. X is normally distributed in brackets with the mean here, and the variance, but we know variance is standard deviation squared. So the number there that is squared will be your standard deviation. All right, we know that any data set that is normally distributed looks like this, okay? The bell curve. We've got our mean here in the middle, okay? It will also happen to be the mode and the median because it is symmetrical on either side of a normal distribution, and each of the standard deviations to either side of that mean represent a certain area under that curve related to calculus. So the percentage of data that will be in each of these places is listed, and we know what those are from our previous experience with the normal distribution. Okay, so for example, if we have a group of people and their heights is normally distributed, make sure you can see all that. It's normally distributed with a mean of 163 and a standard deviation of 6, then this is what that curve would look like. Okay, it's normally distributed, therefore we know that 34.13% of the data the probability of the data there is 34.13%. So 34.13% of the data is between 163 and 169. 13.59% of the data is between 169 and 75. Notice this is our mean. This is the mean plus 1 standard deviation. This is the mean plus 2 standard deviations. This is the mean plus 3 standard deviations. Okay, going back the other way, this is the mean subtract 1 standard deviation. And there are 34.13% of the data in between 157 and 163, or 1 standard deviation below the mean and the mean. 13.59% of the data here, this is the mean subtract 2 standard deviations, and this is the mean subtract 3 standard deviations. Okay, so I tried to draw those identical to each other so you can see we could actually overlap one right on top of another. Okay, that is true for every data set that is approximately normally distributed. That's the information we use. Now, 24C, we're looking at the standard normal distribution. So the difference here is we're now looking at the standard or the standardized normal distribution. So this is a key word here, or it can be called the Z distribution. Okay, so if I draw this exact same curve again, down here, okay, so I've tried to replicate it again, the exact same curve, then we will have our mean right here in the middle again. Now, the Z distribution, instead of saying X is normally distributed, we're going to say Z is normally distributed. Okay, so Z is normally distributed, and then we have to say what the mean and the standard deviation are. The mean for the standardized normal distribution is always, always, always 0. The standard deviation is always 1, therefore 1 squared for the variance, which is still 1. Okay, so 0 and 1. We don't even need that squared there because 1 squared is 1. 0 is always, always, always the mean, and 1 is always, always, always the standard deviation. Okay, so what does that look like on our graph then? Well, this is where the mean is, so that's actually 0. This is where mean plus 1 was, mean plus 1 standard deviation, so that means that's 1, 0 plus 1. Over here, the mean plus 2 standard deviations, that means that's 2. And so on, here we would have 3. Coming back the other way, this place is the mean subtract 1 standard deviation, so therefore it's negative 1. This is the mean subtract 2 standard deviations, therefore negative 2. This is the mean. Subtract 3 standard deviations, so -3. Okay, so the standard deviation always looks like this. No matter what data set we're comparing it to, the standard deviation looks like this. 0 in the middle for the mean, -1 and 1, one standard deviation away on either side of the mean, -2, 2, symmetrical again, -2, -3, 3, also symmetrical. What's the connection between x and z? So we could take this normal standardized distribution, place it on top of this actual data set, which is normally distributed, and we would have a connection between the z and the x, okay? Now, what are x's and what are z's? These are x's, okay? All these numbers here are x's. X has a probability of being what? All of these down here are z's, okay? So instead of calling these x's, we call them z's to distinguish that they belong to the z distribution or the normal standardized distribution. The connection between x and z is this, and this is in your formula booklet. So z, the value that corresponds to the equivalent place of the real data set on the real graph of that data set. This is how those numbers are connected to each other. So let's see if this actually works. Z is equal to x, so 163, subtract the mean, which is, x value. We could take x as 163 if we want it. The mean is 163, so that would be 0. So 163, subtract 163, divide it by the standard deviation, which is 6. 0 divided by 6 is 0. So that's why 0 is connected to 163. Let's try another one. Let's try 169. So if we have 169, get my caps on the markers here. We want to calculate what z is. Okay, so for instance, for 169, subtract 163, which is the mean, divide it by the standard deviation, which is 6. That gives us 6 over 6, which equals 1. So this position and this position are related based on this formula. That happens at each of the places along here, each of those standardized deviations. Okay, we'll explore this more in the next video. Thanks, guys.